Okay, great.
All right, thank you, everybody. So today I'm going to present about ML and data science tech interviews. So to introduce myself, I was previously an ML engineer at Amazon, and I got my master's degree in computer science from Columbia. And currently what I'm doing is I have my own startup, dspractice.com, which I'll introduce later. So it's a website that helps people prepare for ML coding interview questions. So yeah, let's get going. Yeah, so before we start, I'd like to learn more about you guys. So if you can fill out the survey real quick, I will appreciate it. We can just stay here on this slide for about a minute or two so that we can give enough time to everybody to fill out the form. And the reason that I do that is because I want to hear more about what kind of presentations or what kind of topics I should prepare next time, and what is everybody's current status regarding their job search and their interview process, so how I can be more helpful. So I would really appreciate your feedback or anything that you'd like to share through the survey. Also on trend, so it's the link that was in the previous slide. Oh yeah, Anjali just shared. So this presentation is for software engineers, data scientists, machine learning engineers, and pretty much anyone who's interested in ML and want to make a career transition into ML, because I myself made a career transition from Android development into ML. And prior to Android development, I didn't have a technical background. I was a chemistry major. So I like to welcome anybody who is not in the ML space, because it's a really exciting and there's a lot of opportunities these days. So before we move on to like what the ML job preparation is like, I like to go over what's the difference between ML research versus production. So the main thing is that when it comes to ML research, the kind of data set that you deal with is pretty limited, meaning that the size might be small and you're just working in one kind of data set. But in terms of ML production, that's when the model is going to start seeing the kind of data the model hasn't seen before. So as an ML production, as an ML engineer or data scientist, anybody who's in the ML space, we constantly want to watch out for drift, which is the data distribution changes. And it happens so continuously. For that reason, the model has to be continuously iterated. The model has to be constantly updated. And on top of that, we need to update the data, like the new data that we haven't seen before, we have to store so that now we can take that into consideration when it comes to model development. The second thing that we need to pay attention to is, what kind of goal do we have? Do we want to make batch processing ML prediction models, or do we want to make ML models in real time? So these kind of questions are something that ML researchers in academia, they don't really have to answer that, because most of the times they are more focused on creating the models once and publish a paper, and they don't have to face the customers. And the next one is throughput versus latency. So in ML research, throughput is something that they're more interested in, because they just want to train the models as soon as possible. But the model serving latency doesn't really matter, meaning that since they don't have customers, how fast the model makes a decision is not their problem. But when it comes to ML production, it's the other way around, because it matters a lot how fast does the model make, how fast does the model make a prediction or a decision, because when you're using Instagram, you don't want to wait 5 minutes until the model makes a decision so that you can get some recommendation. And the next one is scalability, how fast like our customers start like hitting the ML models, and security, like can we really utilize the data from customers, and reliability, like are the models are still going to be available? Like what if the one model shuts down or this backend server shuts down? So these questions are very similar to ML backend and databases questions, and they also apply to ML production, which doesn't apply to ML research. And that's why this space is pretty interesting, because it's an intersection between research and backend engineering, the problems that people have seen for a long time. But just because it involves ML, it's something that people have not, people are trying to figure out what's the best way to resolve this kind of issues. So can we move on? So this is a typical ML workflow. And we start from data pipeline. So how is the data get validated, and what kind of data wrangling, like cleaning is being done? And then once you have the right data, whether it's from data warehouses or databases or anything, data, you want to split into train and test set. You want to make sure that you do have the test set, meaning that it's a type of data that doesn't go into model training, so that you can predict how well your model is doing. And it's very important because you want to make sure if you should move on to a different architecture of the model, or if you should stay with the current architecture and if it's ready for production. And after that, you want to deploy the model, going through a series of iterations and integration testing, model A/B testing, and most importantly, you want to continuously monitor how model is performing after it's deployed, because of the previous reason that I just said, because the data drift happens all the time. And actually, it's pretty interesting because model monitoring, model deployment, this is an area that a lot of startups are currently trying to get into. And I was just at the MLOps community hosted by Weights and Biases, and they just released the ML monitoring platform. So everybody got really excited about it. And yeah, I just wanted to share that there's so many startup ideas and startup opportunities in this area too. We can move on to the next slide. Thank you. So jobs that are in machine learning engineering. So number one is ML engineer or applied scientist. So I'm just talking about it from Amazon standards, because everybody has a different terms these days. But these are the terms that I will communicate throughout the rest of the slides. So ML engineering, it's more like dealing with the model infrastructure from end to end, starting from the data up until the data model training and the model deployment. So everything related to ML. And applied scientists are people who are only focused on model development or doing research so that they can publish a better paper about their ML. And data scientists are the people who don't necessarily have to do a lot of modeling, but they're more interested in analyzing the numbers and what kind of directions that the teams need to go into. And data engineering is mostly focusing on features. So features are like the kind of data that go into the model. And so in order to make like model predictions really quick, what kind of cache we should have, that kind of stuff. And ML researchers, so it's I'm talking about academic research here, or even if it's in the industry, something that's more R&D focused, which is not production focused. So I'm gonna move on to the next slide. So these are the type of questions that are going to be asked for the previous jobs that I mentioned. Number one is ML algo, meaning that ML algorithms. So I'll go over like an example later. And another type of question is ML system design. And the next question is data structures. This is something that we're all familiar with, and SQL questions and research. So research means like what's like the most state of the art model for speech to text, or state of the model computer vision papers. So this kind of research question is actually usually for a PhD. So if you're coming from not a PhD background, then you don't necessarily have to focus on it, but it might get asked too. So it's pretty like a huge amount of like the diversity here, which makes it difficult as a candidate to prepare for ML interviews. Next. So we're gonna move on with specific examples of what kind of each question that is. So number one is ML coding, ML algorithms. So an example would be here, implements K near its neighbors for binary classification. Another example is implement and fit a linear regression model. Another one is load data from a CSV file, clean and transform it, then save it to a new CSV. Next one is fit a linear regression model to data that is 20 times larger than your RAM. So all these questions are actually previously asked by companies to hire their ML engineers. So this is one of the most common ML coding interview questions. And here's the answer here. And we can move on to the next slide. So in order to prepare for those questions, ML coding interview questions, the thing that we can focus on is basic ML algorithms, which you can learn by taking online classes. That's mentioned all the way at the bottom here, Apply ML in Python by Coursera. I actually highly recommend this course if you just want to go over ML algorithms real quick. And in order to do some of those questions, I recommend my website, bspractice.com. So it's LeetCode for ML. That's how you can think about it. And you can get similar questions from my website. And another thing is I also host mock interviews through my meetup. And here's the link to my meetup here. So you can come to my future mock interview meetup, which I have this weekend, to get a feel for what it's like to what's like to prepare for ML interviews. And another type of question is ML system design. So an example is implement online and offline training pipeline. So what does offline and online training pipeline mean? So offline is something that you just want to make your models on your own to prepare to be deployed in the future. So here, the features of like data are coming in, and then you want to go through optimization, training, evaluation. You create the model and you deploy, boom. And then online is the data comes directly from the customers, and then it makes a prediction. So the model is coming from the offline here. So that's the offline and online training pipeline. And this is one of the most common ML system design questions that people often get asked. And pros and cons of this system is down here, which I'm not gonna go over right now. So you can see the detailed explanation here, data ingestion. So the model between online and offline, it's coming, and then it also has a data preparation process and data segregation, splitting between training and testing, and then model training and evaluation, and then it goes through model scoring. Then afterwards, model performance monitoring so that you can continuously update the model, and that's happening from the offline as well. Next would be like how to prepare for ML system design. So the best thing that I highly recommend is try to make your own ML productionized app using AWS, GCP, Azure, Hugging Face, Relevance AI, and there's so many different different possibilities, options these days. And another thing is you can learn from other people's examples. And I recommend my Medium post here that I wrote about machine learning serverless. So there are different system design that you can have. And this is something that you can, these are how you can prepare for ML system design questions. And next is data structures and SQL related questions. So data structures, it's commonly asked for MLE, ML engineer positions, but for SQL, it's more focused on data scientists. So oftentimes ML engineers don't really get asked SQL questions. An example would be something that we're all familiar with. Given an array of strings, return the top 3 longest strings for data structures, and SQL would be combine 2 SQL tables. And you can practice these this type of questions from leetcode.com as well as stratascratch.com that's pretty much LeetCode for SQL. So previously I went over ML system design as well as ML algorithms. So those questions, including data structures, these 3 are the main questions that are asked for ML engineering positions. Before you're targeting data scientist positions or applied scientists, you don't necessarily have to focus so much on ML system design as well as data structures, which is coding heavy. So most of the coding heavy questions are for ML engineering positions. Yeah, do you need like so this is the overview of what I went over so far. In order for you to study and prepare for ML algorithms, I recommend dspractice.com. And for ML system design, I highly recommend this book. It's an online book, Design an ML System. Huyen Chip, she's a really smart and well-known person in this industry. So it's a really good resource that you can take a look into. And the next one is LeetCode for data structures. And for SQL, stratascratch.com. And for research, if you want to be more up to date with what kind of research in ML is happening these days, you can go to paperswithcode.com and you can have access to the papers as well as their code. And you can familiarize yourself with the ML research like that. So yeah, the main thing is practice, and then it'll lead you to the good path at the end of the day. So thank you so much, everybody, for listening to my presentation. And then I just want to hear from you because I want to make it more interactive. What was your experience like looking for ML jobs? If you're trying to make a transition into ML, or if you're already in the ML space, or if you just want to make a career transition from non-tech to tech, what was your experience like looking for jobs? Did you think you got enough resources? I want to hear from you. Oh, and you can ask me any questions too if you have any questions about my presentation so far.
Hi, I kind of have a question. I'm thinking about pivoting to machine learning or AI path. I have a traditional MSCS as well. And I was just wondering, what does the career trajectory look like for that path? Because it's not as clear cut as being an SDE, you know.
What do you mean by a career trajectory?
Like where, like